Okay. Hi students. So let's discuss about the changing functions. F of x equals mod x. Then the mod x function is defined. Mod x equal x, x greater than or equal to x less than 0 minus x. So this is it changing function at 0? Yes, it is changing at 0. But it's not changing other than 0. Okay. Then find limit x tends to 0 f of x. Second one, limit x tends to 3 f of x. See, to find this limit, we are going to find limit at what point? 0. So check first at 0 it is changing or not? Yes. Then we should find left limit and right limit. So LHN limit x tends to 3 minus f of x. Below 0 mod x equals minus x. So limit x tends to 0 minus where f of x is mod x. Below 0 the mod x equals minus x. Limit x tends 0 minus x. Put x equals 0 here, minus 0 is 0. So left limit is 0. Right limit of x tends to 0 plus mod x. For above 0, the mod x equals x. Put x is equal to 0, 0. So left limit equal to right limit. Then limit exists, the limit of x tends to 0 mod x equal to 0. Next, second one, limit x tends to 3 f of x. The mod is not changing at 3. So, no need to find left limit and right limit. We can find direct. 3 comes under above 0. So, above 0, the mod x equal to x. So, limit x tends to 3 equal to x. Put x is equal to 3 here, 3. The limit is 3. Okay, here, see the difference between this and this. Okay, here also you can find left limit and right limit, but time waste. Here, no need to find. If the function is changing, then we should find left limit and right limit. If function is not changing, no need to find left limit and right limit. Okay, so this is one more question. Mod x by x. F of x is equal to mod x by x, where x not equal to 0 here. Then find limit x tends to 0 f of x, limit x tends to 1 f of x. Mod is changing at what point? 0. So mod x equals x when x is greater than 0 minus x when x is less than 0. Okay. Limit, see, we are going to find limit at what point? 0. So at 0, the mod is changing. So we should find left limit and right limit. Yes, LHN. Limit x tends to 0 minus mod x by x. Limit x tends to below 0. 0 minus means below 0. The mod x equal to minus x by x. Get cancel equal to minus 1. Right limit RHN. Limit x tends to 0 plus mod x by x. Limit x tends to above 0. Above 0, the mod x is x. X by x get cancel equal to 1. So left limit not equal to right limit. Therefore, limit x tends to 0 mod x by x does not exist. Does not exist. Okay. Next, second one, this. Limit x tends to 1. At what point we are going to find limit? 1. At 1, check. Is it changing at 1? No. So, you don't need to find left limit and right limit. You can find directly this. Limit x tends to 1 mod x by x. X tends to 1, either left neighborhood or right neighborhood. Both are positive only. Positive comes under this. So, above 0. Above 0, the mod x equal to x. X by x get cancelled equal to 1. Direct. See, here we done left limit, right limit, here we are not done. Okay, why? Because it's not the function, given function is not changing at 1, it is changing. When it is changing, at that point we should find left limit and right limit. Okay, so this is the example for changing function. For example, f of x equals x plus 2 when x not equal to 2. X is equal to 4. Now, tell me, is it changing function? It's nowhere changing because x not equal to first limit x tends to 1 f of x. Second, limit x tends to 2 f of x. Right? One comes under this or this. This. Not equal to. 2 also comes under this only. 3 also comes under this only. Limit x tends to 3 f of x. Minus 1 also comes under this only. Means if you take 1.1 comes under this only. X not equal to. If you draw the graph here, x is 0 here. 1, 2, 3, 4, minus 1, minus 2, 1, 2, 3, 1, minus 1, minus 2, minus 3. If you take 0, 0 comes not equal to. 0 is not equal to. What is the value 0 plus 2? 2. Next, 1 if you take 1 plus 2. 1 comes under this one. Okay? 1 plus 2, 3. Right neighborhood is 1.1. Left neighborhood is 0.9. 0.9 comes under this interval only. 1.1 comes also this interval only. So 0.9 function is x plus 2. For 1.1 function also x plus 2. Means left and right both same function. So it is not changing at 1. Also 2. Also 3. Also minus 1. Everywhere in the real number it is not changing. Understood? If given x less than 2 separate function, greater than 2 separate if given, then it is changing at 2. X not equal to means for all real number this is only function except 2. Okay? So here for all these problems no need to find left limit and right limit. We can find direct. So limit x tends to 1 f of x. Tell me x tends to 1 comes under this or this. Is it clear? It's x equal to only. This is all real number except 2. So 1 comes under this. 1 plus 2. 1 plus 2, 3. Next. Here I have not done left limit and right limit. Why? Because it is not, the function is not changing at 1. Next. Limit x tends to 2 f of x. 2 also comes under this. But x tends to 2 means x not equal to 2. X not equal to. But below 2 and above 2, this is. X equal to is this is. For below 2, 1.9, this is only. For above 2, this is only. So x plus 2 here. Limit x tends to 2, x plus 2. But x is equal to 2 plus 2 equal to 4. See, the limit value is 4. Your limit value at 1 is 3. Next, limit value at minus 1. Put x equal to minus 1 here. Minus 1 plus 2, 1. That is. In this case, there is no changing. at any point. So it's not changing, means no need to find left limit and right limit. So this is, keep in mind, when the function is, by finding limit, if the function is changing at that point, then you should find left limit and right limit. If it's not changing, no need to find left limit and right limit. Okay. Next, the greatest integer function. I think everybody knows the most important, greatest integer function. Greatest integer function. See, which is denoted by like this: f of x is equal to step x. Step x. Okay, what is the step x value? The output is always equal to n. If x is lies between n less than or equal to x less than n plus 1 for all n belongs to z. N belongs to z. What is the step of 0? 0 is comes under integers. So its integer value is equal to integer only. 0. 0.1. Tell me, 0.1 lies between two consecutive integers here, 0 and 1. 0 and 1. Understood? So, what is the least value here? Least integer is 0. That is equal to this one. N is the least integer. If you take 0.9, step of 0.9, tell me the 0.9 lies between 0 to 1. 0 to 1. What is the least integer is 0. So step of 0.9 is 0. Step of 1, integer value is equal to integer only. 1. If you take step of 1.5, tell me the 1.5 lies between 1 to 2. 1 to 2. What is the least integer is 1. So step of 1.5 is 1. Tell me step of 2, 2. Step of 2.1, 2. Step of 10.3, 10. Why? 10.3 lies between 10 and 11. So which is the least integer is 10. Okay. Now come to the negative points. Minus 0.1. Minus 0.1 lies between minus 1 comma 0. Minus 1 less than 0. Yes, least integer is minus 1. So step of minus 0.1 equal to minus 1. Step of minus 1 is equal to minus 1. Step of minus 1.1. Minus 1.1 lies between minus 2 to 3. Then least integer is minus 2. Step of minus 10.3. Tell me answer is minus 11. Minus 11. Okay. If you draw the graph of step of function, it should look like steps type here 0, so 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3, minus 1, minus 2, minus 3. Step of 0 is 0. Step of 0.1 0, 0.2 0, 0.9 0. Step of 1 is 1. Step of 0.9 is 0. Step 1 1. Okay, 1.1 is 1. 1.2 is 1. Step of 1.3 1. Step of 1.9 1. But step of 2 2.1 is up to 2.9 2. Step of 3 is 3. Like this. Step of minus 0.1 is minus 1, minus 2, minus 3, minus 1. Step of minus 1 is minus 1. Step of minus 1.1 is minus 2. So the graph should look like stepwise. So that's why it's called step function. So it's gated integer function and step function. Both are same. Okay. Now limit. Coming to limit, x tends to 3 step x. X tends to 3 step x. How to find limit of x tends to 3 step x? So first, while finding limit, I said very important point, whether it is changing or not at that point. So at 3, the step x is changing or not? 3. Right neighborhood is this. Left neighborhood is this. So changing. Therefore, we should find left limit and right limit. LHL. Limit x tends to 3 minus step x. 3 minus means below 3. Below 3, what is the value? 2. 2.9. Step of 2.9 is 2. RHL. Limit x tends to 3 plus step x. Above 3. Above 3 is 3. So left limit not equal to right limit. Therefore, limit x tends to 3, step x does not exist. Limit x tends to 3, step x does not exist. Okay? For example, at all integers also does not exist. At 1, 2, 3, 4, minus 1, minus 2 also does not exist. What about non-integer? Limit x tends to 3.4. 3.4, tell me. Here, 3.4. This is a 3.4. Right neighborhood is this. Join the graph. Left neighborhood is this. Okay? Left neighborhood is this. So both are same. Right? Okay. See, 3.4 this is. Right neighborhood is 3.4, right neighborhood is 3 only. Left neighborhood of 3.4 is 3 only. So the left and right value same. What is the value? 3. So then left limit, right limit equal. Therefore limit exists at non-integer point. Okay? So it's not changing here. You can find direct 3.4. Right 3.5 or left 3.3 if you take, the value will get 3 only. Okay, tell me limit of x tends to 4.5 step x. 4. Limit x tends to 5 step x. Does not exist. Why? Because 5 is integer. Okay, below 5 and above 5 different functions. Changing at 5. Below 5 if you take, you get 4. Above 5 if you take, the step value is 5. So 4 not equal to 5. Limit does not exist. So this is step function is changing at every integer. Okay. So by finding at integer limit, then you should find left limit and right limit. So if it is non-integer, there is no changing. You can find direct. Here no need to find left limit and right limit. Next, indeterminate forms. There are 7 indeterminate forms: 0 by 0 or indeterminate form. 0 by 0, 0 into infinite, infinite minus infinite. Okay, and infinite by infinite, 1 power infinite, 0 power 0, infinite power 0. So 1, 2, 3, 4, 5, 6, 7. There are 7 indeterminate forms. Okay, I think you have learned about only 0 by 0 form. So this will discuss during the coaching time. Okay, as per P board theory, only this is enough. 0 by 0 form. Okay, 0 by 0 form. For example, if you take the function f of x is equal to x squared minus 4 by x minus 2, f of x. Here x not equal to 2. If you take f of x is equal to 2 here, what happened? 2 square, 4 minus 4, 0 by 0 form. Okay, which is indeterminate form. If it is 0 by 0 form, how to find the limit? Okay, this is 0 by 0 form, some standard formulas are there. Okay, if you draw the graph here let 0 here, 1, 2, 3, 1, 2, 3, 4, 5. right? If you take 2, at 2 not defined because x not equal to, limit x tends to 2, f of x meaning is x not equal to 2. You take right and left. 2.1 if you take x is equal to 2.1, then f of x will get 2.1 whole square minus 4 by 2.1 minus 2. We'll get how much? 4.1 units. Next, if you take left neighborhood of 2, 1.9. Substitute here, 1.9 whole square minus 4 by 1.9 minus 2. We'll get f of x is equal to 3.9. 3.9. So, you see, as x tends to 2, from as x increases from left to right, okay, f of x tends to 3.9 to 4.1, which is neighborhood of 4. Here 3.9, here 4.1, this is 4. This is called neighborhood of 4. F of x tends to 4, but not 4. Then 4 is called limit of this function. At what point x equal to 2? So this value equal to 2. So this is actually the concept here. If you take 2.1, 1.9, if you take 3.9 at 2 not defined. If you take 2.1, 4.1, both are close to this point. So this point is 4. This is the 4. Neighborhood of 4, these two. Okay, neighborhood of 4. So this is called limit of f and 2. So this is left limit and this is right limit. So both same and equal and exist. Okay. If it is 0 by 0 form, it comes. How to find? There are many methods. Some formulas, standard formulas we need. Some standard formulas. If it is 0 by 0 form, first use the standard formulas. What are the standard limits? Standard limits. First one, limit x tends to 0 sin x by x equal to 1. This is already learned in the first proof. Second, limit of x tends to 0 sin ax by x equal to a. Next, limit of x tends to 0 tan x by x equal to 1. Limit of x tends to 0 tan ax by x equal to a. Limit of x tends to 0 x by sin x is also 1. Limit of x tends to 0 x by sin ax equal to 1 by a. Limit of x tends to 0, same thing you can apply for tan also. X by tan ax equal to 1 by a. Limit of x tends to a, x raised to n minus a raised to n by x minus a equal to n into a power n minus 1. Next formula, limit of x tends to a, x raised to m minus a raised to m by x raised to n minus a raised to n equal to m by n a power n minus n. Okay. What is the value of limit x tends to 1 sin x by x? Tell me. Is it standard formula? No. X tends to 0 means 0 by 0 formula. But it's not. X tends to 1. 1 if you apply here, x replaced by 1. Sin 1 by 1 equal to sin 1. This is. Limit of x tends to 2 sin x by x equal to sin 2 by 2 because it's not the 0 by 0 form. If it is 0 by 0 form, then both use this formula. Limit x tends to 0 sin x degree by x. X degree is different. X degree equal to pi by 180 x radians. x degree equal to limit of x tends to 0, x degree equal to sine of pi by 180 into x by x. So which in the form of 0 by 0 form, if you put x equal to 0 here, sine ax by x, limit as x tends to 0, sine ax by x equal to a. So what is the a here? A value is pi by 180. Pi by 180. Okay, so most of the students will get confused as they will. This is very important. This function is changing by this. So without this, don't find this. Only because of sin x by x is not a 1. So this will be changed by x. So x, this is most important here. X tends to 1. These are standard limits. Right. So these are standard limits. Okay. So limit x tends to 0 cos x by x. So put cos x equal to 0, 1 by 0, which is infinite. This is called infinite limits, but not indeterminate form. Limit x tends to 0, tan x degree by x, but it is not a 1. X degree it is. X degree make into the radians. Limit x tends to 0, tan of x degree equal to in radians pi by 180 into x by x, which in the form of tan ax by x, which is equal to a pi by 180. Okay. Next. Okay.